Okay, sorry about the excessive number of videos for this part of the discussion. The program just kept limiting me to 10 minutes of time. But this will be the last one. We're going to finish out the rest of these here real quickly. So vanadium, I'm sorry. Let's erase this. Okay, so we have scandium and oxygen, and scandium's our first one of these where we've got a transition element. So we go to our transition table. We don't find this in an A column, we find it in a B column. We go to our transition table and find out that scandium always has a +3 charge. And we know that oxygen has a -2 charge. So we know we can just switch the numbers and that will make it work. But we're going to show the other way here. If I multiply 3 times 2, that means I'm going to need to have 6 negative charges and 6 positive charges. And I'm just going to put that right there. So in order for me to balance this, I'm going to need 6 positive charges and 6 negative charges. And so I asked the question, how many oxygens do I need in order to get -6? And I obviously need 3 oxygens. How many scandiums do I need to get +6? And that's going to be 2. So I can either switch the numbers and get this, or I can work it out using the other method and still get SC2O3. Okay, so let's do the same thing with vanadium here. I've got, if I go to the transition table, it's going to tell me that +5 is the most common charge, and phosphorus is in column 5, so it will have room for 3 more electrons, and that will give it a -3 charge, or I could simply subtract 8 from 5 and get -3. So I could either switch the numbers here, or I could multiply 3 times 5, and that'll give me 15, and that means I would have -15 charges and +15 charges. And so I just asked the question then, how many -3s do I need for -15? And that would be 5. And how many 5s do I need to get 15? And that would be 3. So my formula would be V3P5. Okay. Chromium. If I look at chromium on the transition table, it says its most common charge is +3. And because carbon's in column 4, we know that it's going to have a -4 charge. Now, I'm just going to switch the numbers here. I'm not going to do the other one. And so I'm going to end up with Cr4C3. Okay. Iron and oxygen. If I look up iron, we're going to find out that its most common charge is +3. And oxygen is -2. I'm going to switch the numbers, and I'm going to get Fe2O3. Okay. Copper and sulfur. I'm going to find out that the most common charge is +2, and sulfur is -2. These are already balanced. I don't need to do anything else other than write out the formula. Nickel, if I look on the transition table, I'll find out that its most common charge is +2. Nitrogen's in column 5, so 5 minus 8 is going to give me -3. I'm just going to switch the numbers, and I'm going to have Ni2N3. Okay. And then just these 3 last ones here. Radium is column 2A, so its charge is going to be +2. Carbonate is a polyatomic ion. I go look that up in the polyatomic ion table, and its charge is -2. So I'm going to have RaCO3. Both ions are going to just balance. Francium, it's in column 1A, so +1. Chlorine's in column 7A, so -1. Again, this just already balances. Francium chloride. And then potassium is in column 1A, and the polyatomic ion PO4 overall has a negative charge of -3. And so I'm going to say K3PO4. Okay, now you're going to get lots and lots of practice with this. This was pretty good practice. Hopefully you understand all this. I'm going to go back to the presentation here. I don't need to save that. And I do have, I thought I had, I will put on here just in just a second the a link to showing the complete table. And so that's going to be the end of this. Sorry about the length of the videos. And this is the end of part 2 of this. The last part will just be naming of these compounds. So we've got the formulas figured out. Now we're just going to need to know how to name them. Okay? So